The foundation types that we're going to discuss are low to moderate sites that have medium to good soil bearing capacity to start with, and then we're going to move on to sloping sites and areas that do not have good soil bearing capacity, so poor soil bearing capacity. The image that we see behind, we see the edge of the footing, and in this case, in our part of the world, it's very rare for us to use brick for foundation or stone for foundation. But in colonial America, it was much more common because concrete wasn't really something that existed in great capacity until pretty much the 20th century. These are the types of foundations that we will find in relatively flat or gently sloping areas and with good bearing capacity. Slab on grade is what we'll talk about first, and then we'll look at foundations that utilize a crawl space or ones that have basements. Slab on grade with spread footings. You saw this image in your book. So it's similar, and again, keep in mind that this would be poured as 3 different lifts. So the wall portion, the curb is the part that is above the floor. The wall, foundation wall, which I've also called a stem wall, would continue going ad infinitum into the distance until the wall turned the corner. I shouldn't say ad infinitum, but you guys know what I mean. We're also seeing a drainage pipe, which is extremely common near a footing. That keeps the ground from underneath the footing from getting overly saturated. The purpose is to draw water away from that. And we've got our footing, our stem wall, and our concrete slab with the wire mesh. 3 different pours. And again, we've got the little nubbin sticking up of our anchor bolt. Another thing I might add about slab on grade is that slab on grade is often used for modern looking houses. There's a horizontality to a lot of modern aesthetic, and so a lower to the ground house with very little front porch concept is more common, so you'll see slab on grade for that. And also remember, all of our garages are going to be a slab on grade foundation type. For the next, we're going to talk about these in combination, crawl space and deep basement. These are both types that are made with a continuous foundation wall, often called a stem wall, and a continuous spread footing. So the block shape that we see at the bottom is the spread footing. And again, if our soil isn't as good, we get the foundation to have a wider footprint. So we have a wider spread footing. And in these cases of these diagrams, we don't see any internal supports like we saw early on, but we will talk about that in a slide upcoming. The idea about a foundation with a spread footing is that it has to have a floor on top, and there's always going to be a space underneath. That space is either going to be a basement, and if it is a basement, there is going to be a slab on the floor, concrete slab. However, we don't call it a slab on grade foundation. The main foundation concept is these continuous stem walls with our spread footing underneath. And we're seeing 2 instances of walls sitting on top of that stem wall. And if we don't have a basement, it's going to be a crawl space, and that crawl space is going to be either lesser or greater depending on several variables, which we'll go into a little bit as we go on. And here we're actually seeing the top of the anchor bolts. So we see anchor bolts to the left with a nut and a washer, and that is holding on to the bottom of what will be the wall assembly. And in this case, the wall assembly is adjacent to the floor and not on top of the floor. The one to the right is actually probably the most common type of construction that we see, where we have our foundation, then we have a board similar to the one on the left that's lying on its side that is called a mud sill that separates the floor assembly from the foundation, and then we would build our wall assembly on top of this. Again, we'll talk more about walls next week, and you'll see some more building sections through details so you can get an idea of how everything works together. One last thing I wanted to note about internal footings is that at the exterior of a building, we have to have the bottom of the footing be at the frost line. And frost lines are different in different places. So in really cold climates, our frost line is going to be quite a bit underground. And in temperate climates, our frost line might not be very far at all. In parts of Western Oregon, it's 12 inches. Other parts are 18 inches. In Southern California, for example, there is no frost line. So we see different depths that the bottom of the footing needs to be based on that. But when we're building on the interior and providing strip footings such as this, or isolated footings such as we see here, also called pads, we are protected from the freeze-thaw cycle that is outside the walls. Even in an unheated space, there's enough protection that we don't have to dig nearly as deep. And so the depth of the footing tends to be based on the load that's on it and not what the frost line is. We'll be looking at several images of post and piers. This is a round with depth post and pier. This is the sort of foundation that you'll often find under porches and decks where we do need to have some depth. Again, the bottom of the footing, not the gravel base, but the footing itself, needs to be as deep or deeper than the frost line. And in this case, we're seeing a post saddle, it's called, so that U-shaped member has bolts that are cast into the concrete, and then the post is put in and some bolts are added in. A similar sort of look is this, and if you were ever wondering why, if you ever saw some foundations, footings that have this sort of look to them, it's because there's a brand called Solotube that makes heavy concrete tubes in various sizes that relate to common foundation sizes for footings. And sometimes people take it off and sometimes people let it biodegrade. So these are two examples of footings that have been formed with Solotube. And they, in this case, instead of having that more solid saddle, we have a post seat that is connected on all four sides, again added in. And notice that the top is up away from the ground. In general, we try to protect wood from groundwater and also from collecting a lot of water underneath it, because that can lead to rot. So typically that's the reason why we see an open seam here. The previous examples that we all saw were posts. In this case, it's a beam that's being held up by our footings, and a similar saddle, a little beefier than what we saw previously, mounted into the concrete while it's still wet, and then the beam is going from side to side. The beam is holding up the floor joists, which are making this exterior deck. Some interior footings, again, as I mentioned, they don't need to be nearly as deep when they're on the interior. So this is a foundation. I actually see some brick off in the distance that indicates that this is probably an older house. And a new beam has been added in. Probably the floor joists were starting to sag, and this can be a retrofit. So a beam that's holding up the floor joist, a short column holding up that beam every so often, and then an appropriately sized footing underneath. Those footings are often made similarly to what we see in this middle section, with formwork that is made of wood, but I've also seen people use cardboard boxes to create formwork. So they all should be inspected if you have a building permit. So as long as the size is at least the minimum size in two directions and then depth, how it's formed is less critical. There are also precast foundations, and this type we see very often with decks, especially a deck that's lower to the ground, where they are designed to put something in that hole that will help hold up usually a beam, and then the floor joists sit on top of that. More post and pier, the example that we see above, and I'm not going to go into all these details, but these are a little bit more historic looking. So if we had a post and beam situation where our floor, instead of being made with floor joists, were made with beams, we would see a number of isolated footings under each beam. And they, in this case, this is sort of a small little outbuilding that's being shown. Notice it is showing some X's through some of the, between the columns, the posts, to provide some lateral stability. But this would be another instance of a post and beam, and then we'll look at some pilings later on. And these are just some details that are fairly good details. This is a more modern look at how it might be done, whereas this is a little more of an older style.